Welcome to the mix for the wave parameters section on the speed of sound. What you need to know in this mini section of the key area is you should be able to describe an experiment to measure the speed of sound, be able to carry out calculations using distance equals speed times time, know that sound can be reflected and that the energy of the reflection is less than the initial sound, and to be able to calculate distances, thicknesses or depths where sounds are reflected. Some of these calculations will require you to look up in the datasheet the speed of sound in different materials. Speed is the distance travelled in an amount of time. If we're doing an experiment to find this, we can make a sound by banging two pieces of wood together. The sound is made, then it travels towards the first microphone and starts the timer. The sound then continues traveling to the second microphone and stops the electronic timer. The microphones are set a distance apart, so we have a time from one microphone to the other one, and we have a distance, so we can work out our speed. We need to use an electronic timer because the times are very small, because the speed of sound is fairly large. So we would measure, if you're describing the experiment, you need to say what you measure, the distance, with a meter stick. You need to say the time is for the sound to travel from one microphone to the other, measured with your electronic timer. You might be asked about why it's an electronic timer, because of the human reaction time. We can't react that quickly. Or you might be given an experiment where it's using a stop clock and a person, and say how you could improve this. We repeat the experiment to improve reliability, which is what we do for all experiments. Let's say we got a time on our one attempt, we got 4.41 milliseconds. We need to change that from milliseconds to seconds by dividing by 1000 or multiplying by 10 to the minus 3. So we get our time in seconds, and then we can do a calculation to work out the speed. Distance divided by the time, 1.5 meters. Divided by 4.41 milliseconds. That gives us a number with lots of digits in the calculator. We then need to round that up or down to 340 meters per second. Sonar is used by fishermen to find fish. It's also used in industry to look at cracks in materials, also used as ultrasound for pregnancy, the scans of unborn babies. A pulse is sent out to the bottom or the fish, and then it echoes and comes back. So the distance that it's travelled is equal to the speed times the time. The distance to the fish is going to be half the distance that the signal travels. The speed of sound in air is 340 meters per second. That's in the data sheet at the front of the exam. The speed of sound in the water is 1500 meters per second. As the wave is reflected, the time the echo takes to return is divided by 2. To get the distance to the fish. Here's an example looking at a signal on an oscilloscope. The pulse is sent out, this red wave that's shown, and then it is received. If we look at the gap between where it's sent, the peak, where it was received, we've got 4 boxes on the screen. If we're told each of those boxes or squares is 1 second, we can see that it's 4 seconds for the pulse to go out and be reflected back from an object, maybe the bottom of the sea. or another submarine. Okay, notice that the echo has less energy because the amplitude is less. If we look at the amplitude on there, that's 2 squares compared to the 3 that we started. And that's because we have less energy as signals travel further. So if it was further away and taking longer, the signal would be a lot less amplitude than before. So the time to receive it is 4 seconds. The time for the sound to reach the fish in this submarine is 2 seconds, because it was 2 seconds down, 2 seconds back, so it's only 2 for there. So if we want to work out the distance, distance equals speed times time. 1500 times 2 gives us 3000 meters.